Hi guys. Okay, so today we're going to do a little bit of review, and that's all we're going to do for the rest of the year. Just some topics that are important. So since we just finished on regression and statistics, I want to do a little bit more with it. So today we're just going to do some log equation review, and then we're going to go back to a regression question that we were doing after we review this. And then the next day, I pulled some pretty cool data from what's going on right now with COVID-19 and made my own regression equation that we're going to be doing, which will be cool to talk about. Okay, so before we begin, I just want to remind you of two things. One is if I just have log x and there is no base there, remember this is called the common log, and there's really a base of 10. And if we have ln x, which is the natural log, the base is always e. Okay, so we'll need that today. Oops. Excuse me. We'll need that today. Okay, so let's get into a little bit of review. So we're just going to do some log equations first, and then we'll go into that regression equation that we did last week, and we'll use what we're reviewing here. So in order to solve a log equation, we want to take the logarithmic form and we want to put it back into exponential form. And the way we did that was by using, remember, ben, b to the e equals n. So we would circle, I'm just going to zoom in now. We would circle the base, right, that's my b, raise it to the other side of the equal sign, that's my exponent, and come back around. So 2 to the third equals x, so 8 equals x. Let's try it again. B to the e equals n, so x squared equals 16. Now be careful here. If you were to take the square root and get x equals plus or minus 4, remember this can only be positive and this guy can only be positive as well. So x equals positive 4. X to the third equals 216. Okay, so now we'll take you'll either take the cubed root or you can multiply each by the 1/3 power, each exponent, and then this essentially becomes the cubed root of 216 either anyway, but I figure that's good for us to review. So x equals 6 after you throw that in your calculator. Five to the x equals 25. I think I know that we all know that's 2. But remember, we can get the bases the same. And once the bases are the same, set the exponents equal. Okay, 5. We notice there is no base there. That's going to be our common log. The base is really 10. So 10 to the third equals x. So 1,000 equals x. And then here's our natural log, ln of x, so there's really a base of e there. E squared equals x. Now they didn't ask for any rounding or anything, so we'll just leave it at that. Remember, e is 2.71, blah, 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 blah. It's when we have continual growth or decay. Okay, now what I want to do is go back to that logarithmic exponential equation that we finished on in the last lesson. So I believe this is where we left off. We did part A, and I said to you guys, I didn't want to kill you, make you do B and C, but now we can we finished the statistics unit, and we can go back and we can really look at this question, and we reviewed log equations. Okay, so remember what this was. We had wind speed and we had wind chill factor. So part A was write the logarithmic equation for the data rounding to the nearest 10,000, and we did that in the calculator. We wound up with that equation, y equals that guy right there. And now we're going to use this equation to make predictions, and that's what's cool about these models. It says use this equation, find the wind chill factor to the nearest degree when the wind speed is 50. Okay, so we have to figure out, is 50 an x or is 50 a y? So let's take a look. So 50 is a wind speed. So that's going to be an x value. So I'm going to take 50 and I'm just going to plug it in for x. Okay, and we'll do that right down here in my, I tried to like color code everything in the green section. So we have y equals 13.0134 minus 7.3135 ln of 50. And then you'll just throw that right into your calculator. And we'll get negative 15.597. And they want the nearest mile per hour, so that would be negative 16. Alrighty? Okay, and now for part C. Okay, I'm gonna go like this because I don't want to be too far down. So I can see the equation still. All right, part C, based on this equation, if the wind chill factor is 0, so now the wind chill factor is 0, wind chill factor is my y value. So I'm going to plug in 0 in here, but I'll still have x there now. Okay, here we go. So 0 equals okay, looking like this. And now we just have to solve. Remember, we're solving right here for x, but x is attached to ln. So I'm gonna, and I cannot put these two guys together. Okay, that's not happening. So what can I do? And you guys were so good at this. I think you would tell me to subtract 13.0134. That's a long equal sign. I mean negative sign. Oh, that was an equal sign and a negative. Oh, goodness gracious. Okay, so we're looking like this. And now we'll divide through by the negative 7.3135. Divide through. Oopsie. Okay, we're left with 1.7793 equals ln x. Now this is why I didn't want to do this question the other day, because I figured, you would forget how to solve this. So now we know how to solve it though, because we reviewed. When there's no base for ln, it's e. So this is e to this power equals x. So e to the 1.7793, blah, 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 equals x. And now we could just throw that right into the calculator. And we get x equals 5.926. They wanted us to round to the nearest mile. So x equals 6. Okay, so I hope that was a good review right there for you guys. And tomorrow we'll do another regression, but we'll do it with some real data with everything that's going on right now. All right, bye.